Hey everyone, Mr. Voikin here, and in this instructional video we're going to take a look at building a transistor nightlight on this virtual breadboard in Tinkercad. We will be following the schematic diagram over to the right and introducing a couple new components. So number one would be the LDR, which is a light dependent resistor, and a transistor right here. In this case, it is an NPN transistor with the call out numbers BC547. And below the schematic diagram, you can see the pinout for that component. So when the transistor is facing you, that is the flat side with the writing on it. The numbers will be imprinted on the flat side of the transistor. The left leg is the collector, which on the schematic symbol is the top lead coming in on the top right here without the arrow on it. The base is going into the middle, and that's the middle leg, and the emitter is the one on the bottom right with the arrow facing downwards. Now, so far I've got the breadboard set up, connected to a power source, which is a 9-volt battery. And so that is connected up top on our schematic diagram, and our positive rail up top is connected to the positive rail on the bottom through this jumper wire right here. And although unnecessary in Tinkercad, these small little jumper wires in the middle here are there to demonstrate if you have a breadboard that has a gap at the center point on those rails, you need to jump it from the left side to the right side. Now the ground input from the negative terminal on the 9-volt battery is not running directly down to ground, because we're going to first run that through a switch. So this slide switch, I'm going to connect the common leg to the input from the battery terminal, and then we're going to take a diode, connect the cathode or the negative side to the other terminal, and the positive side or the anode down to the ground rail, and essentially that completes this portion of the circuit right there. Okay, so let's take a look at our photoresistor, the LDR, light dependent resistor. I'm just going to make a copy of it, and then I'm going to bring in a multimeter here from the right hand side, and I will set it right now. It defaults to voltage, so we're going to set it to resistance. So because this is a light dependent resistor, let's go and check out how the resistance works on that. So I'll connect terminal 1 on the resistor, and then terminal 2 on the resistor. And now what I'm going to do is just run the circuit, and if I click on the LDR, you can see it brings up this little slide bar. So right now it's at dark. So at darkness, at full dark, excuse me, let's go to the pen. So at dark we have 180 K. And if I slide that over, you can see that the resistance starts to decrease as it gets brighter, and at full brightness, so at full brightness on this one, we have a total of 506 ohms. Okay, so we can see that when it's dark, that is going to be high resistance, and when it's bright, it's going to be low resistance. Now, I'm just going to build a slightly different circuit just to demonstrate this, how it's working right now. So if I was to put the LDR in here and connect this part down to ground, and I'll bring a resistor in over to an LED and then complete this path down to V+. So essentially what we're going to be doing is coming in up through the photo resistor, through this protection resistor, which because this LED actually, or sorry, the LDR is only going down to 506, I wouldn't really need it to be 470 ohms. That's going to take the sum of those two resistance values and make it about 900 and close to 80 ohms of resistance. So really I could probably put this down to like about 10 ohms, and that's going to be enough. So as we know, when it's bright out, I've got 506 ohms, which is going to be low resistance, and current should flow through, lighting up the LED. But for a night light, we want the opposite to happen. But when it's dark, we're going to get 180 kilo ohms of resistance on the LDR, which is essentially going to stop any of the current from flowing through into the LED. So let's just test this, start it, and when we're dark, you can see we have high resistance, and as we get brighter, the resistance decreases and the LED becomes brighter. So that is not what we want to happen with a night light. We want the opposite. So we are going to deconstruct this circuit for the moment, and then we will build it as we see it over in our schematic diagram. So let's first connect the LDR down to ground, and it's a non-directional component, so we will just bring it in and bring one of the leads, the one on the left is most logical, using a black wire down to ground. Now the other side of the LDR is going to, it's got sort of two options. It can head up to that resistor or over to the transistor. So first I'm going to connect it up to my 100K resistor, which is right here. So I'll put that across this gap in the middle. I'll run a jumper wire between that leg and our fixed 100K resistor, and then we will run that up to V plus as indicated in the schematic diagram, and we now have that pathway complete. So let's take a look at the transistor, and the transistor has a flat side and a sort of curved or rounded side. We want to position it so that the flat side is facing us and the legs are moving from left to right, as you see in the diagram here. Now this is an NPN transistor, and if you hover over the pins, you'll see there's the collector, the base, and the emitter, which is exactly as we see in the symbol on the pinout of the BC547 here. Now what a transistor does is it acts like a switch and or a amplifier. So basically, once the current, a small amount of current is received at the base, it allows current to flow between the collector and emitter. And if there is not enough current at the base, then no current will be able to flow between the collector and the emitter. And essentially, the greater the current that is received at the base, the higher or more current that will be allowed to flow between the collector and the emitter. So if you look over at our circuit, when it is dark, it's going to be low resistance, which is going to allow the current, if we're looking at electron flow, to come up through the LDR, and it's going to come up to this point right here, and it's going to run into the 100K resistor, and it's also going to flow this way over to the B leg on the transistor. Now, current likes to take the path of least resistance, so the greater that we make that resistor, the more current that is going to be sort of blocked by that resistor, and the more current that will head over to the BC547. So this one, we could adjust this by, increasing or decreasing the resistance value of that, which would essentially change the sensitivity of the LDR to the light. Okay, now if we look at our schematic diagram, we can see that the bottom right lead, the one with the arrow facing out, which is the emitter, which is the right leg, is connected down to ground. So I'm going to take that leg and run it down to ground and color coordinate that to black and just double check. Yes, that is the emitter. So we have completed that portion right there. Now we can see that the middle leg, which is connected to which is the base, is connected in between this 100K resistor and the LDR, which is essentially here or here. So I will take a jumper wire between here and here, and that will be turquoise in this case. And I now have that part finished right there. The only thing left to add into this circuit is our LED and the resistor. Now the resistor connects to the positive side, the anode on the LED, and it is a 470 ohm resistor. So I will change that to 470 and rotate that. And we can just run that directly to positive down below. And essentially the C leg is connected to the negative leg on the LED. So I will do that like so. And that finishes this leg of the circuit and completes our circuit in entirety. So at this point, we should be able to run this circuit. So I'll turn it on, and the switch was already turned on. If your switch is off, you will need to turn it on, and you can change the brightness sensitivity with this slide right here by clicking on the LDR. So I will turn it to bright, and once I turn on my switch, the LED should be off. That's good. And if I slide that switch over, it should eventually turn the LED on, and there it is. So in this case, you can see that the sensitivity didn't really happen to you. We were almost at complete darkness right here. Now remember, I told you previously that if we change the value of this resistor right here, then we will change the sensitivity on this LDR. So I'll change this down to say a 1K, which is quite a difference, and we'll run that simulation again. And now we can see that we are dark, and of course it's on, and as I keep going up, 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 getting closer to the brightness, it is still on. And in fact, when I get to full brightness, it's still on. So we do not have enough resistance right here to allow current to go through into that B leg. There's just such little resistance right here that it's taking a lot of the current is going straight back into the battery through the resistor. So let's stop the simulation and let's just split that in half. So we'll change this resistor to 50 kilo ohms, run the simulation again, and let's see what happens. Well, there it is, it's on when it's dark, and not much different really than the 100K. So let's just change this down to say about 10. Run it again. And now the sensitivity on that LDR is set pretty good. So I'm happy with that. However, if I did want to have the sensitivity to be adjustable, I could just replace this fixed resistor with a potentiometer. So if I slide a potentiometer into this point right here and then run this side up to the middle leg, just double check, no, that's not where I want to be. Go over to that leg right there. And now if I was to start the simulation, turn my power on, set this to where I want the sensitivity to be, and I can turn the potentiometer until, well, it's right at the bottom. It's not really doing anything, and that's probably because, yeah, if you look right here, the potentiometer is set at 100K or 250K, which is too much. So we saw that it was pretty good around, say 10K. So if we were to set this at like, say 22K and now run the simulation, somewhere around the halfway point should be where I want it to be, right there. So you can see that's about where it turns on, and I can set it right to the point where it's going to just start coming on at the halfway point right there. Okay, one last thing we can do with the circuits. If I want to, you can see up top we have the resistance portion of the multimeter checking out the resistance on the LDR. If we slide down to the bottom, I can go grab another multimeter and we can check the voltage or current. So I'll set this one up to amperage right now, and the way the current is connected, or a multimeter is connected to read the current, is it has to be like built into the circuit. So we literally need to like remove this wire right here, and then we're going to run these two legs off of the multimeter into sort of this point. So the current would come through here, through the multimeter, back out and to where it was going, which is the middle leg right there. And now if I run the simulation, and you can see at this point when it's complete darkness, we have 754 milliamps of current, and as we slide to the right, the current begins to decrease, and as it decreases, then the LED also becomes dimmer. So that's how the transistor is working, a little bit like an amplifier. And the way it works like a switch is literally when we crank it all the way to the right and there's 0 amps of current going through there, then the transistor is not allowing any current to flow through the collector and emitter. So anyways, there's the circuit with a little bit of added theory, so I hope this helps.